But the name, it's Gaussian. Gaussian is Gauss Jordan. The other one is called Gauss dash Jordan because it was introduced by Gauss, and I think later it was further developed by British mathematician. His name is Jordan. No. Two names. This one is called Gauss or Gaussian method, and this one is called Gauss Jordan. Okay. So Gauss, yeah. It's reduced echelon form. Yeah. It has the name of the method and the name of the guys who introduced it. Okay. Yeah. Okay. So this echelon form refers to Gauss. The reduced echelon form was further developed, as I mentioned, by Jordan. So that's why it's referred to as Gauss-Jordan elimination. So guys online, did you get any answers for the first assignment? Anyone got answers? Yes, you got? Real numbers? Exactly. Okay, so the answer for this one is first one, X is an R and X is X is in the real numbers minus, if you like, 0 for -4. This is the answer. Okay, guys online, do you have any problem with that? Or shall we solve it together? What would you say? I will I will upload the answers immediately after the class, but what do you prefer? So, shall we solve it? Okay, I will do it quickly. So the determinant of x for 0, sorry, question number 1. The determinant of x for 0 for x0 and 0, 0x. Okay. So I hope everyone can see it clearly. So this is equal. Remember, the method, you take this one here for with positive, then negative, positive, and then you reduce the column and the row where 4 arises, then you get a 2 by 2. So you multiply here this x times the matrix that has x 0, 0, x minus 4. Then if you just cancel this column, this row, you get 4, 0, 0x plus the last one is 0, and then you reduce this one to, let's write it, 4x 0, 0. Obviously, this one will cancel to 0. This one cancels to 0, so we don't need it. So remains this. And again, how to evaluate this? You just multiply this, a 2 by 2 determinant, multiply this diagonal, and then subtract from this diagonal. Multiply this diagonal, subtract from this diagonal. So if you reduce it here further, you get ultimately here x multiplied by x squared minus 0 minus 4 multiplied by 4x minus. If you simplify it, you get x to the power 3 minus 16x. Now you set this equal to 0. Why we set it equal to 0? Because we want to know which values will cause this to be 0 and exclude them, okay? So here you just take x as a common factor and then you end up of having x squared minus 16 is equal to 0. And then this is x times x. I hope that everyone knows that this is x minus 4x plus 4. This is equal to 0, okay? From this, you get x equals to 0. From this one, you get x equals 4. So you set each of them equals to 0, okay? So this is x equals negative 4, okay? So the final answer here is x is in R, and you exclude these three values. So these values here will assure you that this determinant is not equal to 0. So this is the answer to this question. Any problems, any comments? So okay, let's have a look at the second question here. If you don't have any questions related, as always, I do the mistake right on this nice projector. So now the second question, I just put it in 3 steps because, sorry, because usually even in I give points to these. So I just try, it's a sort of bonus. And also, usually when I put the question here in this sequence, it means that everyone is built on the previous step, okay? So that means here you have, this question has 3 parts. The 3 parts are just built on each other. So first part here, you write the equation here as in a matrix form. So in matrix form, it means here you have the coefficients matrix multiplied by the variables matrix is equal to the right-hand side. So here by default, this is 1, right? This is 1 by default. This is 1. For instance, here you see that y is equal to 0, right? The coefficient of y. So writing this in this form is the first step. Then you take the coefficients matrix A and then attach to it the right-hand side, this column, yeah, 9, 8, 3, to get what we call the augmented matrix. And then you work on the augmented matrix on step C to reduce it either to the echelon form or to the reduced echelon form. Again, echelon form, upper triangular, reduced echelon form, you go all the way to get the identity here to the left. Okay, guys online, if you manage to get any solution, just please write it on the chat here in the class if you need any help. So I will show you for this one the solution for the first 2 parts here. If you like to check your answers here, this is question 2. So it's straightforward actually. It's just rewriting the linear system in this form. This is all. Here you have to be careful for the fact that For instance, 0 here is the coefficient in the third equation. You don't have y, so you set it equal to 0. And this capital X is actually the one column vector that contains all of the what we call variables or unknowns. And here, right hand side is very easy. You just get the constant there in one column. Here, this one. So this line here, it belongs actually, it's just a separation to the left. So you know that ultimately what you need to do is to get only this part here. This part you get in the upper triangular form. Okay. But any operation you will do on any of the rows, you need to do it. You need to do it for the entire coefficients, right? For the whole for the whole row, not only for this part here, the left, also here 9, 8. Okay, guys, is this clear? Richard, are you saying something? I can't hear you, but okay. And regarding this part C of question number 2, there is no one way, as I mentioned, to do it. So you might start with a step. I start with another step. So later I will be uploading the solution. It's just a proposed solution. It's one way to do it. Of course, there are many other ways. Let's see. I know we are going to do these three exercises, basically. Did you solve everything? Yeah. What did you get for the second one? Okay, let me see. Please have not shown the online lecture. Okay, so I can just show you one way to do it. This is C here. And I just stopped here at the echelon form. Okay, so this is the echelon form. So as I told you, systematically you work each step. You have in mind which of the elements. So here what I usually do, I start with this A and put B next to it, the augmented matrix, and then you have to work along this diagonal, okay? So everything below the diagonal you need to eliminate. So this first step, just eliminate this. I multiplied R2, R1 with negative 2 R2 and subtracted, so I got this. So as you see here, we eliminated 0. Then I divided by 5 to just make it straight. And then in this step here, I eliminated this P here. And it's there, the, the echelon form. And from this, always keep in mind that this column refers to the X coefficients, this Y coefficient, this Z coefficients. And then from down upwards, you will be solving the equation. Of course, you can reduce further to get this here, the identity. This is the called reduced echelon form. You will be getting the answer here. The solution is 2, -1, and 2. You get it right? Yeah, did you go all the way to the reduced echelon form? Okay. Ah, the inverse. Ah, so use, no, this is good because next week I was uh, it's not easy. No, it's not easy because you need more steps there. But next week I am thinking of maybe bringing this same or using these two methods left, the inverse matrix and the so-called Kramer's rule. Okay. Now here I have a student, Richard, now joined. Today is my second time joining. Uh, well, Richard, I can't go back the scratch. We have already, I don't know how many, 10 lectures. But what you can do, I uploaded everything actually online. There you find the lecture, yeah, so lecture notes with the summary of the topics of the chapters that we did so far, and then you find worksheets and the corresponding solutions. So please go there and try to okay, so just go this and let me know if you need further assistance, okay? We're going to have a mock exam before the holidays, so try to study and solve some exercises and let me know if you need help. So Amna is asking how many points. This is difficult to say, but maybe 10%, 10% of the exam, such question, or more, maybe 10, 12%. But Amna, why are you asking? Because you are sure you will get these points, or you are afraid? You wouldn't, so don't know. Solution mechanism. Okay. See, I will be uploading this right now after this lecture. I will be uploading the answers. Mm. Okay, so what did you get for the last question? What was the answer? An inverse matrix. No, no, the last one, if you add them together, number three. Yeah, the identity, I mean, the identity matrix. Yeah, okay. 1, 0, 0. This is the right answer actually. Okay. It's possible, yeah, it is possible. You know, we will learn later that you can you can try to get the no, I see here x different sides. We will learn later how to solve matrix equations. So you multiply with the inverse because, as I told you, there's no division. So you multiply by the inverse. I don't know whether if you multiply by A inverse here, and the thing is that you see that X is on one time to the right, one time to the left, and it makes big difference. But if you multiply with A inverse from both sides, well, I'm sure if no, multiply all the equation with A inverse. So sometimes if you multiply with the inverse, you get the identity. So if you, for instance, what is A inverse? So the determinant is 1/2, right? 1/2 will not help you. Eh? So it will 1/2, then you flip 1 and 2, and then -1 will become 1 because the determinant. So you remember the rule for the 2 by 2 matrix. No, no, it's worth trying actually to just try to get. You remember the rule we said that if you have a 2 by 2 matrix, right? So A equals, let's say, A, B, C, D, right? And the determinant of A is non-zero. This is important, okay? Then what is A inverse? A inverse is 1 over the determinant of A, right? And then here inside, you just flip D and A and minus B and minus C, right? Okay. So here it would be, what was it? What was the equation there? Okay. I don't know, either A or X, you can 2, 0, -1, and 1, right? 2, 0, -1, and 1. Okay. So the determinant is 2, but the reciprocal is 1 over the determinant, right? Okay. And then here inside you have 1, 0, 1, and 2, right? And here, if you go back to the equation, you have it's 1 times x plus x times A transpose, right? Now here, if you multiply everything with A inverse, sorry, so if you multiply with A inverse here to the left, then you get here A inverse A x plus x will not help you. So here anyway, you will be getting I, yeah? But here you can't say you will be getting I or something. So it will not help. But this method. Maybe next week we will have a couple of exercises how to solve what we call matrix equations. And if you want to solve, of course, you need division, but we don't have division. And to get over this fact, we multiply with the reciprocal, with the, of course, with the inverse to get rid of the number. Okay. So for instance, here, if you want to solve for x, you can't divide by a, right? But to eliminate a, you multiply by its inverse if it exists to solve for x. Okay. So this technique we will use next time. Okay, so this solution of that one, I can. So I hope that everyone understands here. This last lecture, we did the so-called multiplication of matrices. Maybe we can do this one together, at least one of them. Then we will see how we get the final answer here. Okay, so I have here an equation, matrix equation. I'm given the matrices, very simple, 2 by 2 matrices, and then I will just plug them in and try to solve. Okay, so this is A. So it requires A, which is 2, 0, -1, 1, multiplied by 1 over 4, 1 over 12, 1 over 12, 7 over 12. Okay. Let's do it one by one, then add them up together, plus x, which is 1 over 4, 1 over 12, 1 over 12, and 7 over 12, multiplied by the transpose. Transpose of the matrix is just you make the columns rows. So here 2 minus 1 and 0. Okay, so this A transpose is just flipping the rows and columns. Okay, so let's start by multiplying out these. Just to remind you the rule, you take the first row, multiply it with the first column as a dot product. Okay. So this one, maybe I'll do it because we have students here who are new. So 2 times 1 over 4 plus 0 times 1 over 12. So this is the first element. Then the second, so this is the result. If you like, this is the result. This is 1, position 1. The second one, I multiply this with this column also as a dot product of vectors. So here you multiply the 2 with 1 over 12. Then you add it to multiplying 0 with 7 over 12. Okay. Second element here. Then I have here the second row again, I do the same. I multiply it here like dot product with this one. So this is the third position here down. So what I got here is negative 1 times 1 over 4, right? Plus 1 times 1 over 12. And the last one here, I multiply this row with this column. So I got negative 1 times, again here I have 1 over 12. I add to it, multiplying 1 with 7. Yeah. Now, if we simplify this, this is 1/2, right? 1 over 2. Now, this one I got 1 over 6. 12 over 2 to over 12. This one, what do I get here? 6 over 12, right? 7 over 12 minus 1 over 12. 6 over 12, which is 1/2, right? 1/2. And then could be minus. Here, I got 1 over 4 minus, okay, 3 over 4, 1 over 6 minus, okay? Okay, so here I got minus 2 over 12, which is minus 1 over 6. And here the last one, I got 6 over 12, which is 1. Okay, so this is the first part. Just this part. Okay. Now, this part here, this part, we do it also the same. Similarly, we multiply this out. Let's do it. So here you need to multiply this row here with this column, then with this column, with this one here, with this and this. So you got all in all the 4 elements. So here, this one, I'm multiplying out this part here. Okay, so 1 over 4 times 2 plus 0, okay, times 1 over 12. It doesn't matter here because you have just 0. Now the second one here is just 1 over 4 times 2. And then I have here plus, again, 0, 0, which is 0. 2 times 1 over 4 plus 1 over 12 times 0. Okay, let's see. And here the second row, I become 1 over 12 times negative 1 plus 7 over 12 times 1. And here I got 1 over 12. This is, sorry, this is times 2, right? This is 2. Sorry? Yeah, x multiplied throughout this one. Okay, so the first one I have 1 over 12 negative. Okay, the last one. Again, okay. This is 1 over 12 times 2 plus 0. This is 0. And this one here is 1 over 12 times negative 1, right? Plus 1 over 7 over 12 times. Okay, so let me see what I get here. 2 over 4, 1/2. Here I got why I got here 2. Okay, the second one is multiply this one with that one, right? Minus 1 over 12. I got minus 1 over 6, right? This one, I got 1 over 6. This one, 6 over 12, which is 1. Okay. Now add these two up. So the final answer here is you have 1/2 plus 1/2, 1 over 6 minus 1 over 6, and minus 1 over 6 plus 1 over 6. And here again, was 1/2 plus 1. So the final answer here, you go to, this is the answer here, 1, 0. Okay, so I will be uploading the answers. Actually, I can do it now. Seven. Okay. Okay, if you want to check the solution, it is online. Okay, the solutions for this worksheet that we did today already. Check it. So please, for next week, if you are not joining the rest of today's lectures, just make sure that you uh, this reduction, the three rules here, the so-called elementary row operations, make sure that you know how to apply it, and we will get some exercises how to evaluate, for instance, the inverse of the 3 by 3 or 4 by 4 matrix using this elimination method. And very important also, next week we will study the Cramer's rule, and Cramer's rule is entirely defined using the determinant. So determinants of 3 by 3, how to evaluate it, you saw today in your first question, for instance, is important. And talking about the determinant, this is something I just want also you to maybe verify always. Here, if you, before you start here, it's a good attitude, you check that the determinant of A is not equal to 0. So here it's important. Why? Because this means this linear system has a solution. Okay. Because if you start here and then you start with this equation and this determinant is equal to 0, you will be deadlocked here while reducing. You will end up of having maybe some equation that doesn't make sense or contradiction. So in this case, it's good attitude ahead of evaluating any system of linear equation to check whether the coefficients matrix is non-zero. Okay. Let me check. Is there? Okay, guys online, check the answers. Let me know if you have any comments or if you need any further explanation there or any further assistance. Okay, so we agreed now just regarding our, so to speak, roadmap until the holidays. I will be starting with maybe, as I told you, next week with Cramer's rule and some equations regarding matrices, and then we will make a mock exam. I will make it on one day, the mock exam, and then after the mock exam, instead of the tutorial, we are going to solve it together. Okay. So maybe we'll spend 2 hours for the mock exam and 2 hours for the just having a look at the answers of the mock exam together before we go to the, okay. So I urge you to practice. So I keep telling my students, studying mathematics is just learning how to ride bicycle. You can't learn it theoretically, okay? You need to practice, get the assessment of what you need to improve for the exam. Okay, so if you don't have any questions, actually, we can leave it there. And for those who didn't join the class yesterday, we will be having 2 sessions at 5 time. Okay, so the answers for the worksheets are online. Please check them. And for those who are leaving now, have a nice day and until next week. Any questions, guys, online? Do you have any questions? No questions? Okay, so thank you for joining. And after the break, we will continue with the group for today. The other group, we will see each other next week. Goodbye.